Okay, so today we're going to take a look at this little automatic antenna tuner. This one is marked ATU-130, and actually this one's marked Max, the ATU-130 Max. The listing just said ATU-130, so whatever. And this is another one of these little, compact automatic antenna tuners. They are all over the place. There's a bunch of different variants. Some of them seem to be clones of each other. This one here on eBay is the one that I ordered. It was in the U.S. This isn't the exact listing I ordered, but I also ordered one in the U.S. It was right around $100. You've probably, if you're at all familiar with these, you've probably seen these little guys. This is the more common variant, the ATU-100. Very simple, just RF in and out in the form of two SO239s, and then a big tune button. And then these have an integral LiPo. And then that's it. But they just have the one button. All they have is a tune button. So for a quick press, you can reset it or press and hold to tune it. This one belongs to a friend of mine. I wanted to test one out because I was thinking about getting one. My main rig, the ICOM 7410, it has a built-in ATU, like a lot of modern HF rigs do. But also like a lot of modern HF rigs do. It's only, it can really only match up to about 3-to-1. Beyond that, it's not so great. But then I also have an older rig like this Kenwood TS440 that I'm restoring, and then I've got a couple little rigs like this. This little QDX digital transceiver, which there's obviously no tuner in here. So it's useful to have a standalone one. Another nice thing about these two is that they display your output power level, which I really like. My rig doesn't display that. It just displays a bar graph, between 0 and 100, and sometimes I want to see more specifically. Same for SWR. These display specific SWR numbers. However, this one has a limitation. The ATU-100 has a limitation that the ATU-130 doesn't have, and that is it cannot be put into a bypass mode. At least I don't think it can. So there's another version of the ATU-100. Like I said, it's kind of hard to keep track of these because there are a bunch of different variants. But there is this variant of the ATU-100, which does have the same three buttons that the ATU-130 has. The bypass button in particular is that I'm talking about, as well as an auto button. I haven't looked closely enough at the inside of the ATU-100 that I have in front of me. You may be able to add in these buttons easily enough. I'm not sure. This one also has a DC 12 volt hookup, so you can feed power directly into it. So I don't really know. It's hard to tell. There's not a whole lot of information, about a lot of these, right? They're kind of lacking in information. Specs wise, the ATU-130 specs, they kind of float all over the place. I don't know how much these are actually tested. But, compared to the ATU-100, faster microprocessor, better relay, better capacitors, bigger magnetic, I assume they mean toroids, heavier wire, greater power tolerance. I haven't used it with more than 100 watts yet, so I don't know. I don't know if it has a greater tuning range or what. It's a lot. I don't really have the tools to really quantify tuners, but I can say that this one so far has performed pretty well for me. And I think given the cost of other commercially available auto tuners, it's sort of a personal decision. So, yeah, I kind of already covered why I lean towards this one over getting my over just getting another ATU-100. The biggest ones are the ability for a bypass mode and the ability to power it directly off of 12 volts. Now, granted, the ATU-100 that I literally just showed, well, it has those capabilities, right? It's got a bypass button, and it's got 12-volt input. So why did I go with the 130? I don't know. It was different. It was different. I kind of like the look. I don't really like the 3 mismatched buttons. Whatever. But I've got it. I was perfectly happy with the price, and I am very impressed with the performance. This might just be luck of the draw, but for my environment, for my tests, I am able to get better matches, and I'm defining a match by having lower SWR on the ATU-130, this guy, than my friend's ATU-100. This one is marked Pro Plus. I don't think these markings mean anything. Honestly, I don't even think the model numbers mean anything. It's just whatever the manufacturer likes the look of, they slap on there. So as far as what the package came with, in addition to the tuner, it also came with a barrel jack, one of these with a little plastic shroud that you can unscrew so you can solder on directly. So if you want to build your own power cable, and a pre-assembled power cable, this is about 8 inches long. A banana jack, because this one does have a banana jack connector on the back. I'll show that in a bit when we take it down. And curiously, a PL259 connector, but no reducer. So and it's funny. This is you look at listings for the ATU-130, and you'll see it, without a reducer. And, my suspicion is just whoever is packaging these doesn't really know what they're doing. They're just grabbing a part and throwing it in there. I don't know. It's kind of funny. And it's got these giant windows on the sides. I haven't seen a PL259 like this before. So, throw it in my connectors junk box, and maybe one day I'll find a reducer that fits, or maybe one day I'll have a need for a PL259 that doesn't have a reducer. I don't know. Yeah, so now we're going to talk a little bit about, I guess, how it works and stuff. So the way I have it in my setup here, let me swing my monitor out of the way. I love these monitor arms. So the way my station is set up here is very simple. We've got the 7410 down here, and then it is running directly into a coax switcher. It's running into the A input. I guess actually the A input. And then the output of the switcher is running straight into the tuner, and then the output of the tuner is running straight into the coax that's running up to the antenna. My antenna is an in-fed half wave, so the wire it's cut for 80 meters. It's about 130 foot wire, between 132 and 135, something like that. And then it's going through a bound box that I've got wound as a 49-to-1. And then if I tilt the camera, I've got a choke right there. That's just a 1-to-1 choke. That's about, 18 inches or so behind the connector for this, but it's just in line. I don't have any additional connectors there. And the reason I've got it set up like this is so I can switch between the rig and then which is on A on the switch, and then on B, got the Nano VNA. And I really like this because what I can do is I can just have, and I know this doesn't look great, but I've got Nano VNA Saver up here, and I'm running a sweep from 3 megahertz to 30 megahertz. And we're just taking a look at, the sweep of the antenna, and it's, as it's tuned. So I can sweep the antenna through the tuner. So what I can do, let's switch bands here. So I can just take you through the procedure. I'll zoom in a smidge. And I know it's crooked, I'm sorry. I'll try and square it up. So let me drop the power way down to like, I'll call that 10 watts. And then we will switch to 40 meters. And then I'm just going to tune down a little ways from FT8. And then what I'll do is I will put this into tune mode, and then I'll press the tune button in the software, and it's done. So now if I press tune again, you'll see power we're generating, and that ALC is cranked up way too high, or the power output in WSJTX, so I can drop that down. And then also if I zoom into the tuner, you can see, yeah, we're putting out about 11 watts. We got an SWR of 1 to 1.1, and or 1 to 1.11, and 99% efficiency. So I'm going to turn that off. Now, for 40 meters, that's not really super representative because my antenna is already really good at 40 meters. So just as a comparison, I'll switch it up to 20. So I just switched it up to 20. And then I'm going to tune again here. So this does have an auto tuning mode. I haven't tested it yet. The way it works is you just click the auto button, and then in between the two first values, you'll get a little square that represents auto. Like I said, I haven't tested it, but you just hold down the tuning button until it says tune. Again, we're on 14, or 20 meters, tune down a little bit. Hit tune, use some clickety clicks. It got an SWR of 1.06. And on the ATU-130 Pro Plus that I've borrowed from a friend of mine, on my antenna in this exact configuration, doing exactly what I just did, I wasn't able to get better than about 1 to 1.5 or 1 to 1.6. So this gets me a better match, but that might just be the luck of the draw. So now what I can do is let me zoom back out here, tilt back up to look at the screen, and switch over to Nano VNA, saver, and then I'm going to switch my antenna switcher over to the Nano VNA, and then I'm going to run a sweep, and I've got markers set at 80, 40, 20, and 17, and I can zoom in a smidge here. I don't know why this is so dark. And then let's run a sweep. So we can see our SWR figures all across the band. And something I really like is if I go back to the tuner here, I can switch it into bypass mode. So here we can see inductance, it's got switched in 0.4 microhenries and 100 picofarads of capacitance. And I can just click this button, and you'll hear a relay fire, and it's now switched in 0, and there's a little underscore there, and that means it's in bypass mode. And so if I zoom back out, and I set my current sweep as a reference, and then I run another sweep, we can see how exactly that tuned configuration differs from how it's running. So in this case, you can see it's not a tremendous difference. You know, for this antenna, which is already, pretty resonant across these bands, the tuner is basically acting as like a cleanup tuner, right? But something I can test is, here you can see, for example, let me delete my reference. You can see this marker that I have up on 3940 kilohertz. That's where a net that I often participate in sits, and right now that's above 4.3. That's at SWR 4.4. So you probably wouldn't want to use that. Like, you could, but it's not great, right? So let's pull that one down instead and see how we can get that one to tighten up. Because you can see here at the very bottom of, so that would be, I guess, 75 meters, and then here, closer down to maybe 3.4 or 3.5, and we have a really low SWR, so we just need to smidge that over a little bit. I'm going to take this out of bypass mode, and I'm just gonna pop over to here, and I'm just gonna switch it over to AM, because AM has a continuous carrier. And you gotta remember to not transmit into ground, so switch our antenna switch over to the radio, and make sure there's nobody transmitting. It sounds pretty dead to me. And then what we're going to do is we're going to go ahead and hit tune here, and then transmit. And we heard the relays fire. We got an SWR of 1.15 to 1.2, so that's great. And so now it's switched in 3.2 microhenries and 320 picofarads of capacitance. So we are going to switch back to Nano VNA Saver, switch back to the Nano VNA. We're going to save our current sweep as our reference, and then we will sweep it again. And so now we can see this red marker here where my net operates is really nice. It's got SWR of 1.3. It's, it's somewhere between 1.1 and 1.3. But everything else is way out of whack, right? Which is kind of what you would expect. But it's just a good example of how this thing works. Something that I'm going to experiment with, and I will certainly make a video on it if I do it, that this rig, this ICOM, does, of course, have an ATU output, and you can modify these little ATUs to pull that in as, to have them fire off automatically. And the nice thing about that, there's really two nice things about it. The first is just being able to use the tuner button. And that's nice, well, for a couple of reasons. So one, when you have an external tuner connected and the rig knows there's an external tuner connected, the rig will not try and tune. It will keep its internal ATU disabled. And in my experience, sometimes if an external ATU is taking a little bit too long to find a match, the 7410 will turn on its own ATU, and you don't really want to be running through two tuners. And so it can take like a couple of cycles to get it dialed in, and that can just be annoying. Whereas if you tell the ICOM, hey, I'm running an external tuner, it just won't. It won't even try with the internal. So it would be nice if you could do that. If you could like forcibly disable it and keep it disabled, but whatever. The other nice thing is that it generates a nice 10 watt, continuous wave carrier when you do that. So there are some folks who have made I think it's called like a quick tune or a click to tune maybe, which is basically a button on a cable that plugs into that connector, and you press that button and it tells the rig that you're running a tuner, and it also has it switch on that 10 watt continuous wave carrier so that an ATU that you're using, if it's one like this, can then do what it needs to do very easily. So that's kind of an initial look at how the ATU-130 works. For my particular setup, it works very well. I'm very happy with it. I haven't tried it with a less resonant antenna yet. That is something I would like to do, and I'm going to try and do that in a couple weeks here for field day. Oh, Marco says hello. Hi, Marco. Yeah, so far my initial impressions are very good. I definitely think that it's worth the money. I think it's a great value. So what I'm going to do here is I'm going to get Marco out of the way and reconfigure my environment a little bit, and I'm going to go ahead and pop it open, and we'll take a look at the insides. Okay, before I take this thing down and open it up, though, I did want to show one thing, and that is the relay situation in here. Some tuners, like for example, this LDG AT7000, have what are called latching relays. And latching relays hold their state even when they're powered off. So you can tune, and then once it's tuned, the auto tuner can basically entirely turn off. In the case of the ATU-130 and the ATU-100, probably others, the relays are not latching relays. And so that means when power is lost, they will revert to whatever their normally open configuration is. Which in this case, I think that just means bypass. I'm not entirely certain. So I just wanted to show that real quick, because I know that's something that folks might ask about. So what I'm going to do, first off, let's get the camera pointed back at the tuner. And then I'm going to take my lav mic, put it right next to it. And I'm going to turn it off. And you should hear a very loud click as everything resets. And then it does remember its last state, though. So if I turn it back on, here, click, click, click. And then it pulled back in. It's 0.4 microhenries and 147 picofards. So I can also put my lab mic back on. Can also, of course, show this in the software. So let's reset our reference. I'll run a fast sweep here. Oh, let's switch this back over to the NVNA and run our fast sweep. And then turn it off. Set this as a reference on another sweep. So you can see it's different. And I can confirm whether or not this is in bypass mode by resetting our reference, setting this as our reference, turning it on, and then if we sweep it again, they should be inverted. And they are, like I expected. And kick it into bypass mode, sweep it again, and now the sweeps should match, and it looks like they pretty much do. So that's just something to keep in mind. I don't know exactly what the power consumption of this thing is. My guess would be, so based on the figures on the listing are, between 300 and 400 milliamps while tuning. And then my guess is in standby, it's tens of milliamps. So if you're, running super QRP off of a set of AA batteries, this probably isn't the rig for you. If you're trying to run super remote, super low power. But for benchtop use or for running on a park, sitting at a picnic table with a big, lithium iron phosphate battery or a big, lead acid battery, whatever, I don't think it's really an issue. I don't think it's something to think about. Of course, alternatively, there are these guys, which have built-in batteries. But the downside is when it runs out, you have to recharge it, right? So anyway, or you can run it off of a USB cable, though I don't know if it's really designed for that. So with that, let's go ahead and turn it off. I'm just going to go ahead and turn everything off, too. Turn off the radio, turn off the tuner, turn off the power supply, and it's going to screech at us. All right, so, oh no, okay. All right, so here we go. Here is what we are working with. So here's the device. I'll set it next to the ATU-100. See, it is a little bit bigger. It's a little bit longer. They're both on feet, but the 130 is a tiny bit taller. And then width-wise, almost the same. So very, very, very similar. The screens are also different. You know, the ATU-100 uses the bigger, I think it's 128 by 64, whereas the 130 uses the 100 is 64 pixels tall, the 130 is 32 pixels tall, if I remember right. Let's look around the back, and specifically, let's look at the 130. So DC 12 volts in, just a standard, I believe it's called the N-type barrel connector. It's, 5.5 millimeters outer diameter, 2.1 or so millimeter inner diameter. Again, SO239 connectors, as well as this banana jack, and it comes with the banana plug. So if you want to run just a random long wire, you can do that. And then it has a ground stud, and there's a wing nut too, but I took that off. And that is actually something I really like about this one, that it has a ground stud. The AT100 doesn't, and so you kind of have to patch together your own solution if you want to use it. Like the ATU-100, the screws holding it together are 2.5 millimeter hex. And the front and rear panels are circuit boards, which I think are really clever. I think that's a really good method for putting plates onto these extruded aluminum enclosures. So go ahead and open it. And you know what? Since I've got it here, let's go ahead and open the ATU-100 as well, so we can compare them a little bit better. Alright, then I think get some more light. Take off their lids. Alrighty. So here they are. I didn't really intend this to be like a comparison video. I'm not really qualified to do that kind of comparison. But just looking at them, you can see the way that the relays are configured is a little bit different. In the 100, you have the relays sort of on either side of the inductor bank, and all of the relays are the same. And this is smaller wire. I've got a set of calipers over here somewhere. I can measure it. I used to be really good at quickly identifying magnet wire, but so let's see. This stuff is, let's call it 0.36 millimeters. Oh, I'm on inches. 0.9 millimeters. And then this is 1.2. You know, so that's a good bit heftier. The relays in here are IKE brand. It looks like they are all HRS 1H, or I think that's a 1HS. And I think these are all the same. And then there's some Celastic in here to keep them from wiggling around too much. And then here you got your little power and SWR measuring transformer. This lens doesn't really want to focus that close. And looking at the panel, you can see how the connections are made. It's really interesting. The connections to for ground onto the plate itself these are crimp lugs, but the plastic has been removed, and they've just got them soldered directly onto that. So that's interesting. And then here you can see these are the individual caps that are getting switched in. So, 10, 22, what's that? 47 or 4.7, 100, 200. So there's all the caps that get switched in. We're switching in the capacitance. There might be more on the bottom. I don't really want to take this all the way apart. It's kind of hard to see, but the battery is underneath there. And then the front panel, also lots of Celastic here. So here we've got the LCD. This is just a totally off-the-shelf I2C OLED LCD. That's why when you view them on the screen, they have a little bit of a flicker because OLEDs refresh a little bit slower. And then there we have the microcontroller. I'm not entirely sure. It's a PIC. I think these both use PICs. That's what the original design used. Whatever, it's a PIC. It's documented for the ATU-130 spec. And then you have something a little bit wacky coming in. The battery connector. Kind of hard to see down in there. You can see a battery connector, but the battery's just soldered straight in. And I can see a little transistor. It might be a voltage regulator. One of the wires for the battery is going into this diode, so it's got a protection diode in there. I don't see any other. I had mentioned earlier that this board might also have an interface available for enabling a bypass mode or a manual versus automatic mode. I think it's just got the single button. So this button is the same as the tune button on the 130. Whatever, we're not talking about the 100. I just wanted to compare them. So let's set this out of the way. Let's take a look at the 100. So, as I mentioned, as you can pretty clearly see, much beefier coils, much heavier wire. I found, and this might just be the case of these particular units, but I found that the ATU-130 does not measure power very accurately. It seems to be reading like 20, anywhere between, I'd say, 15 and 30 watts high. I don't know if they can be calibrated or whatever, but that's just something to keep in mind. The construction's a little bit different. We've got the coils are over here on the side. I see some isolation slots cut into the board, which is really nice. It's got the same design with the caps running along the side, but they're not labeled. I like that they are labeled on the other one, but whatever. And then this one, C2, looks like one of these high voltage, like mauve types. But let's see if I can make out what it is over here. It's a 225, but I think it's a 225. But you can see the soldering. Let me zoom in. I don't know if it'll focus this close, but we can see. The soldering's good. I mean, I opened this thing up before I turned it on, just because well, one, I'm always really interested to see how this stuff is constructed, but two, I'm a little bit skeptical of this kind of stuff sometimes. And I didn't see any shorts, but it's definitely it's very dirty. I should get a Q-tip with some isopropyl alcohol and see if I can scrub that down. Another thing that's a little weird is the way that the screen is attached. It's barely attached. So the way they did this, it's kind of wild. And I think you can see that this connector, like they soldered this. So there are 4 holes on the edge of this board here for the data clock, power, and ground. And I think they swapped out the header for something with longer pins, and then they pushed them about halfway through. And then on the front panel, they wrapped the pins so they turned to be parallel with the board, and then they soldered them onto the front panel there. Because those are just soldered on there for mechanical strength. They're not actually putting any data there. The data is coming, or the data, power, and ground is coming over this cable, going around, and then plugging in here, which doesn't. When I first saw this, it looked like it was disconnected, because I am used to seeing, headers that have this little like plastic, whatever spacer holding the pins together. And this does not have that, so it's really, the pins are just coming straight off the board. And I kind of gave it a wiggle. I can try and use a little pair of pliers here, and oh, you know what? I bet those are male pins, and I bet they're pushed in there and soldered. I assumed that those were female, but I bet those are male and they're pushed through and soldered. That's a little bit janky for me, but yeah. What are you gonna do? Also, so there is this header, and it is marked MCL, VCC, ground, data, and clock. Maybe that's MCLR. I'm not sure. I'm not really sure what this header is for yet. I don't know if it's an in-circuit serial programming type of interface for this chip, which again is a big PIC. Looks like this one is a PIC 18F2520, something like that. So, it's dirty. There's a little bit of jankiness, but the soldering seems good. Granted, I haven't fully disassembled this thing yet, because in the ATU-130, you can see that the board is on standoff, so you can see screws there, and there. What's interesting is I don't know if the standoffs are just glued in place. I don't know exactly how those are held in. They might just be for height. But on the 200, these extruded aluminum enclosures have rails in them. In fact, you can see it very clearly if I look at the top half. If I kind of pull it to the edge of the frame here, you can see there's a slot here. And that slot is for running a PCB into, and they're really nice and secure. It's a very good way to secure a PCB into these enclosures. But because both the front panel and the rear panel are soldered in place, they're kind of like holding it in. They're like squishing it in. So if I wanted to pull the panel forward or backwards, I think the easiest one to do would be the front one. So you can see I could desolder the wires going into this power switch, and then I think I could just pull this forward and swing it up, and then slide the board out the back. Because if we look at the RF interface section here, we can see that the center pins of both the RF connectors are soldered directly down to the board, which I really like. I think that's a very nice, robust job. And then running along the bottom, there's like the ground bus, and you can see the tabs of the SO239 connectors. There, how it's run through there. Interestingly, it's not. So this screw, it's kind of hard to see. This Phillips screw head is what's going to the ground lug here, and they're like 1/4 of an inch apart, and they're not together. And it's like, why didn't you do? But it's on this panel. This back panel is flood filled with copper, and I've measured the impedance on it, and it's less than 1/10 of an ohm. So I think that's a fine ground. It could be better if it were bonded to that piece of magnet wire, and maybe one day I'll get aggravated enough by it that I'll pull this thing apart and I'll do that. But I really think that's unnecessary. Frankly, I think this is perfectly fine as is. But you can see this little guy right here. This is the banana jack. How it's just tapped directly off the center, the active pin of the output, right? So we could have a random wire antenna and just plop it in there and be good to go. It's nice to have that as an option. You just have to have a counterpoise, and you have to have a wire that's the right length. That's actually, because what you're putting together is like a sloppy dipole if you do that. But anyway, yeah. So this is how this thing is constructed. I'm perfectly fine with it. I mean, there are some things that could be better, but I think given the cost and its performance, it's fine. The relays. This has 2 types of relays. There are these guys. I think I can zoom in a smidgen. So yeah, there's whatever these are. I can't quite make it out. And then these are JZC 32Fs, specifically 012-HS3. I don't know. They've got 2 banks of relays. It seems to perform well. So I guess that's it. Again, neither of these have latching relays, but that's something that you're going to expect out of a much higher end tuner like this. Of course, a tuner like this is going to cost, $200 to $250, and it doesn't have like a nice screen on it or anything. And on this particular one, you really just have to connect it to your radio and let your rig's interface run it. And these are good. LDG makes great tuners, but if you want something that's that's got the little screen, I don't know. They're just different options. It's good to have options. What I'm really interested in too is you can get both of these as kits for like way cheap. I'm pretty sure the kit version of the ATU-130, or maybe it's like a ATU-200, it's like $30. And I'm interested in getting one of those and putting it in my own enclosure. And that way, you could have both DC and 12 volt DC input and an internal battery pack that you could disconnect, or whatever. So if you need that internal battery and you want something that you can take into the field, the ATU-100 might be a better option. If you want something that has a little bit better power handling capability, that has that manual bypass switch, maybe the ATU-130 is the better option for you. There are other variants out there Now there's even an ATU-130, right? So there's a number of different options. So yeah, that's pretty much all I have to say. I think the one thing too that you might want to think about is that these often have trouble tuning at lower power levels. That said, the QDX, I've configured its power transformer such that it puts out about 6 watts at 13.8 volts. And both of these, when that's putting out a continuous wave at full power, both of these can tune perfectly fine at 6 watts. But some people say they really want at least 10. So, I don't know. Again, it's like, I don't know if I'm just getting lucky or what. But just some stuff to think about. But I think if you are looking to expand the equipment that you have in your environment, that you have available to you, and you're interested in a tuner so you can play around a little bit more with different types of antennas, I think these are perfectly viable options these days. I think you do kind of have to be careful, try and look for models that have information out there, which again is part of why I'm making this video, because when I wanted to get this thing, I did some research and I was really surprised to not see a single video, or I think I found one, but it was like an unboxing or maybe just someone taking a video of the listing. So I figured I'd, spend a little bit of time with it, get familiar with it, see how it operates in my environment. And, yeah, I like it. I think it's good. So I think if you're looking for, a little cheap ATU, I think this is a perfectly good fit. So I hope this was helpful, and thank you for watching.